Good morning, everybody, and thank you very much for joining us for today's webinar, a specification-based approach to embodied carbon, discoveries, challenges, and opportunities. My name is Felix, and I'm the webinar coordinator at the Continuing Education Department here at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from today. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we commence, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. We highly encourage engagement through our Q&A window. Feel free to submit any questions you may have for our speaker. These questions will be addressed in the designated question and answer period at the end of the presentation. Kindly note, the chat function will be deactivated following this introduction. For those seeking continuing education learning hours, please note that attendance is important. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please allow some time for the processing and reporting of these hours. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the need of our diverse audience. But now, I'm excited to introduce you to our speaker for today's session. Please welcome Lara Gumushdjian. Lara, I'm passing it over to you.
Thank you so much, Felix. Nice to meet everybody, virtually at least. I'm really excited to be able to share this really great initiative that our office has done in collaboration with a number of consultants, and really be able to kind of distill that and disseminate that information, that knowledge sharing through to the rest of the profession and all of you that are listening. So let's maybe begin, and I'll walk you through what it is that we're going to be talking about. So a little bit of context, we're going to be walking through some of the initiatives as it relates to the objectives of the exercise that we set out to do, how we sort of started, how we sort of engaged in this exercise of looking at our specifications, looking at the decarbonization strategies for it, but also really looking at the sort of spectrum of decarbonization. There's a lot of different methodologies that are available as tools for ourselves as architects, but really understanding that there is actually another tool that we can be able to sort of highlight and accentuate and utilize. I'll then sort of walk you through the process that we underwent in developing their decarbonized set of specifications, and really sort of walking you through what those defined terms are. What does a decarb spec mean? What does a spec-based approach mean? Among many other items as well. Lastly, I'll walk you through some of the findings, which is really quite shocking. We certainly were interested to see the results of the investigation that we had done, and I'll sort of outline what those are, and really specifically highlighting the information gaps. And then, of course, as it relates to the conclusion, just some of the opportunities and really the takeaways for all of us online to be able to kind of consider. So maybe just a quick introduction about myself and, of course, our company. So for me, as Felix outlined, my name is Lara. I'm an architect and director of sustainability here at KIRKOR Architects. We are an architectural firm that does specialize in high-rise residential mixed-use projects. So we do a lot of point towers, a lot of community builds, and we do a lot of master planning, as you can see from some of the images. We've been around for over 40 years. Have done a number of projects, not just within Ontario, but across Canada too. And one of the things that we started to realize quite quickly within these past few years is really having to do with an increasing demand for sustainable solutions. So for example, our clients, we were speaking with our clients, they have specific goals for their own corporate objectives for decarbonization, but also as it relates to the municipalities that we're working in. Green development standards are really outlining in full force strategies for decarbonization, and really as it relates to embodied carbon caps, life cycle assessment reporting, et cetera. So there's really quite a sort of growth and increase in those kinds of requirements, but also as it relates to discourse and conversation. So one of the things that we recognize quite quickly is, and it was really just having to do with an understanding of what these goals are, an understanding of what embodied carbon is, and really finding ways to better service our clients. So how do we help them actually get their carbonization goals in check and in line and executed in a project, but also as it relates to things like your submissions, how do we ensure that with the coming legislation and policies that's being put in place through the green development standards, how do we ensure that, say, through your rezoning site or your site plan application, you can actually meet the requirements for decarbonization? So we really recognize that there was an opportunity here to be able to act to ensure that not only the project, but our clients are happy. And really, that came in the form of looking at our standard specifications. We wanted to really be able to identify what we had to kind of set out the sort of baseline, as I've noted in there, of what our carbon values were for our specifications. And in that, we would be able to understand what the offsets could be when we actually create a decarbonized set of specifications. So that would be through the use of those low carbon alternatives. What would those different materials be? What would that actually render as your global warming potential? A lot of these terms I'm hoping and I'm assuming some of you guys know, but if not, please do let me know and I'll try and expand on that. But also we wanted to sort of develop a bit of a hybrid specification, really offering our clients the opportunity to kind of pick and choose between those standard specifications that we use on all of our projects through our master outline spec, but also as it relates to opportunities for them to retrieve and utilize some of the low carbon products and within the decarb spec. So offering that kind of flexibility was really important. Now you guys might be asking, why did we jump to the specification? Well, the specification is, and what I'm actually arguing as part of this particular webinar is that it is a decarbonization strategy. It is one of those items that we can actually utilize to full extent in really being able to define what the carbon value is, what that GWP is for our products within our specifications, but also in a more grander scale as it relates to quantitative information. So I'll put a pin in that in a minute because I do want to touch on the existing strategies that we have right now. These are more of the qualitative strategies, just as it relates to your design considerations, some quick material substitutions. I've outlined them there as being your design-based and your broad stroke. So a little bit on design-based. You might have heard a lot of sort of discussions around ensuring that you're doing efficiencies in your structure, minimizing your terracing, using less material, perhaps even a reconsideration of your programmatic locations. So for example, if you wanted to do your underground, maybe consider doing it as an above grade system, so forth. Even as it relates to your broad stroke strategies, what are those high carbon products of your structure, of your envelope, and what could those low carbon alternatives be? So for example, if you had a high carbon concrete structure, you'd be able to kind of look at an eco-pact or a low carbon product, and also as it relates to maybe even changing the structural system in its entirety, things like considerations for your mass timber construction, et cetera. So those are kind of the existing strategies that we have as tools I do want to highlight that they are very, very successful with regards to reducing a significant amount of our embodied carbon within our projects. But I wanted to be able to highlight that there is another tool in our toolkit, and that is through the specifications. Really being able to utilize the tool for execution and implementation so that the design-based strategies that we've worked so hard on at the beginning of your project, say in schematic design or design development, can actually then be executed in its entirety on site and as part of the actual life of the project. So one of the reasons why I say that it's a quantitative sort of strategy is that in your specifications, you're actually looking at a significant volume of materials. So for example, your design-based strategies, your broad stroke strategies, they're really looking at your 1 to 10 products. But your specifications is really looking at hundreds and hundreds and hundreds of products. And I'll kind of dive into that a little bit more in the forthcoming slides. But you might be asking, well, that's really important. That's really great. But say, for example, we don't necessarily have a proprietary specification. So proprietary specification allows you to be able to outline what those materials are per division. And you'd be able to kind of have that sort of volume or database of materials to choose from. And materials to be able to utilize, whether they're low carbon or in your standard specification, your basic materials. That's not a problem. You can still implement decarbonization strategies and methodologies. And again, I'll share with you what those are, even if you had a performance-based specification or a prescriptive-based specification. So what is a specification-based approach to embodied carbon? I've sort of seen it as being literally taking your master outline specifications and really just channeling it, funneling it through, filtering it through your life cycle stages of embodied carbon. That sort of integration of your life cycle stages is really an important piece to be able to shape the actual DNA of your specifications. And really that's taking into account everything from your product stages of your A1 to your A3. That's basically having to do with your actual extraction of your raw materials, your transportation, and your actual manufacturing, right through and into the remaining section of your upfront carbon as it relates to the actual installation and transportation of your products on site. And then, of course, right through and into your use stages and then into your end of life stages. So really being able to actually understand what those life cycle stages are. How does that actually apply to your project through implementation, and how you can actually translate that through as part of your actual specifications? How do you actually translate that into there? So those are really the kind of, I sort of saw this as being a visual illustration of it. The actual work involved to be able to do that is far more nuanced, and you need to have a team to be able to kind of help you in really understanding what each of these components are. So your spec writer as it relates to your specifications, whether that's in-house or external, but also with regards to your sustainability consultant and really fundamentally understanding what embodied carbon is, what are the life cycle stages associated to it, and then what are the relationships that between the spec and the actual embodied carbon stages that you can actually find those overlaps, implement them, and execute them. So this was the concept that we wanted to achieve. We didn't want to look at those few materials. We really wanted to look at every single product within our master outline specification. How did we do it? Who did we attain? What were their expertise? So I'd like to be able to sort of touch on that a little bit, starting with our sustainability consultant. We brought on Half Climate Design in the form of Kelly Alvarez-Dorn, but also with Ryan Brewer, and special shout out to Sarah Hassan. Ryan was really kind of the spearheading the understanding of the actual carbon values of the standard specifications, the products within our standard specification, to really understand what that baseline was, as I mentioned earlier. But also as it relates to defining and understanding what those low carbon alternatives are, so that when we actually create that decarbonized set of specifications. We actually have quite a lengthy list of materials and products that were low carbon that we could then be able to use in conversation with our clients, with our sustainability teams for those respective projects and for execution. So that was the sort of roles and responsibilities for our sustainability team. We also brought on our specification writer in the form of BBS. A special shout to Daryl Duggan and Brian Ballantyne, who really were spearheading the sort of translation of what that meant in our specifications. So for example, the vetting process, this was another sort of key piece that we wanted to be able to do, is not only understand how we actually translate the terminology, the requests for EPDs, et cetera, into the specifications, but what does it mean as it relates to the low carbon products? How do we ensure that those low carbon alternatives are working for the typology of work that we do as it relates to Part 3 and high-rise residential mixed-use projects, but also as it relates to the code compliance and testing. That's a bit of a spoiler alert. I will elaborate a little bit more in the later slides. But also being able to then communicate to the team, not just ourselves as the project manager, but also as it relates to our sustainability teams, to ensure that whatever lessons that we have learned through this process is then communicated to everybody. So for example, if there's a low carbon product that might not be viable for whatever reason, that would then be communicated back to the full team to ensure that we understand that this particular product still needs a little bit more time for development and for testing, et cetera. So we'll just put that on the back burner, but keep it in mind potentially for later when industry manufacturers are ready to go. As it relates to ourselves at KIRKOR, we had a really great team comprised of our partner, Brent Whitby, but also as it relates to our own directorship and sort of specialists, material specialists, assistant directors with Howard Tuckman and Eric Johnston, and then myself really being able to kind of spearhead the initiative and understanding what the findings were, what the information gaps were, how we document that, ensuring that we're working together as a team with regards to the schedule that we had. But then, of course, sort of, gathering all this information together and really creating that ultimate report, and hopefully in the objectives of really resolving that decarbonized set of specifications. What was the scope? This was the team, these were the responsibilities, but what was the scope of work? What were we trying to actually highlight and understand in greater detail? You can see on the screen there, we looked at every single product within divisions 3 through 9, so everything pertaining to our structure, our envelope, and also our finishes. We wanted to make it very clear from the beginning of this exercise that we did not want to look at a handful of products. We wanted to look at every single product. Overall, it was around 625 products that we looked at, which was a very extensive look into every single division, every single section, every single manufacturer and product associated to it. But I also want to be able to highlight why we looked at beyond our Division 3, our concrete as we know, and beyond our envelope as it relates to our thermal and our openings for Division 7 and 8. I think this is really an important piece and something that I would certainly encourage the other architects online to be able to look at, is that we have to know that although the green development standards are really looking at our structure and envelope for the moment, and certainly as it relates for the next few years, we have to be able to kind of future-proof the work that we're doing and be smart. Let's be prudent. This is an exercise. We brought on the consultant team. Let's understand and utilize that time to be able to examine things beyond structure and envelope, because at some point in time, those green development standards will be looking at things beyond the structure and envelope, things beyond our typical materials that we utilize all the time in our projects. So future-proofing that, being shrewd with the time that you have, thinking prudently, certainly helped us sort of get bang for our buck in our assessment. but really looking at it in a very holistic point of view, which I think is also really, really quite important to be able to kind of drive home in this conversation. I did highlight in this slide in red Division 1, which is really our general requirements. Why did I do that? Is because quite honestly, we realized that it was actually a very pivotal division in our specifications. So this is kind of what I was mentioning earlier to say that, you know, if you don't have a proprietary specification, and you have maybe the prescriptive or the performance-based specification, how can you actually implement sort of those decarbonization goals, those strategies within the spec? If you don't actually have materials or products associated to it, you can still do that. Your Division 1 does that. It accomplishes that. It allows you to be able to request for EPDs. It allows you to be able to address the validity periods of your EPDs, because EPDs have a validity period. They are only valid for a certain period of time, and I'll touch on that in the next slide. But also as it relates to material substitutions. So for example, let's say at time of your IFC, you know, you've specified a particular product that's low carbon, but later on during construction, for whatever reason, that needs to be substituted with another product. So how do you actually ensure that the material substitution that that needs to be done on site for whatever reason that may be, how do you ensure that those material substitutions are working with the actual life cycle assessment that you've done, and the sort of global warming potential or carbon value of that project that you want to be able to maintain? So thinking about all the things, those things is really very important, and really explicitly outlining them in great detail is also going to help you get there. And I think submittals is a key tool for that. So consider those things. So I said a lot of really important words in there. EPDs, GWP, all of those things. What do all of those things actually mean? Again, I want to be able to kind of expand on this a little bit for those that might not know what these terms actually are. So what is an environmental product declaration or an EPD? It's basically your certificate. It's essentially a report that basically outlines what those environmental impacts are of that particular product through its life cycle, through its actual stages of embodied carbon, which is one of the things that I mentioned earlier in the slide. So what are those actual environmental products, or rather environmental impacts that we're talking about? It talks about a lot of things. You might think that an EPD is just sort of associated to your global warming potential or that carbon value of your product. But it's actually talking about a lot of other things. It's talking about ozone depletion, which is basically how much damage can that chemical in that product actually, you know, distill down or remove or affect that ozone layer within our atmosphere. It talks about acidification. So how much acidic qualities can it create in the water, in the soil, and same with eutrophication as it relates to the number of nutrients that it's providing in water and in soil as well. Smog formation, there's a whole scientific term for this, but basically it is what it sounds like. Does the product actually create particles in the atmosphere, which then creates smog? But I wanted to be able to highlight in there a global warming potential, which is really basically your carbon footprint. It is your carbon value. Really being able to understand what those that value is essentially in short terms. So why is this important? I thought this was a really important line item to add in the slide deck, because really it's multi-layered. The need for data, which is being generated through your EPD, is great. It's important for us as private sector representatives and members, because we need to be able to help our clients, and as I mentioned earlier, meet their corporate objectives for decarbonization, understand what that carbon value is for the project as a whole. That's why we have our life cycle assessments, which is basically understanding what that carbon value is for the entire building through its entire life cycle. Public sector, it's important for them too, because they want to know what that value is, what that carbon footprint is of your project. And they are the ones that are actually legislating it and putting it into policy. It's important for industry manufacturers, and I want to be able to highlight this in great detail because industry manufacturers, I've said this before in other conversations with some team members and even externally, industry change cannot happen without industry. So industry manufacturers need to have a table. They need to be involved, and they need to know that it is actually in their interest to be able to generate EPDs, because they are going to be able to be having a bit of an edge as it relates to a market, having that knowledge leadership opportunity. And frankly, it's also giving them a seat at the table with private sector clients, developers, architects, even sustainability consultants, of course, to be able to highlight and advocate for their products, how they're being responsible, how they're being transparent. These are all really very valuable things. There's a huge business case to this. And again, something that we can be able to advocate for in conversation with our industry manufacturers to say that, you know, if you don't know what an EPD is, let's talk about it. I can walk you through it. But also, if you do know what an EPD is, but you're hesitant to be able to get it, you should, for these valuable reasons. So I think that's really an important piece to be able to highlight. I think it's also important to note that EPDs does have limitations. As I mentioned earlier, there is a validity period. There is an expiry. So these EPDs only last for a certain period of time. Usually it's around 5 years. But I also want to highlight that EPDs, depending on the rules in which have actually been set for the EPDs, which is in short form product category rules, or PCRs, basically the rules for when you actually create your EPDs, that it actually is only showing a moment in time of that product, the carbon value of that product within certain stages of its life cycle. So for example, I've noted cradle to grave as it relates to your A1 to A3 versus the actual life cycle of the entirety of that product in embodied carbon from A to C stages. So you have to be careful in understanding what those limitations are, and really actually encouraging manufacturers to consider not just your sort of cradle to grave, but also as it relates to looking at the full life cycle. So if there's an opportunity for the rules in which these EPDs are being made to be able to show the full life cycle, that is obviously the way to go. So something to consider. So those are just a bit about the defined terms and processes, but I also want to be able to highlight that not every EPD is the same. And this is actually something that Ryan at HAF really helped us in creating that kind of taxonomy of EPD types. There is a difference. Some EPDs are very accurate. Some EPDs are so inaccurate that there's literally no data whatsoever. They actually don't even have EPDs associated to it. So really being able to understand what that kind of sliding scale of accuracy is really an important piece. And I'll dive into what each of these things are, but I kind of envisioned it as being a kind of a village of EPDs. Each EPD has their role to play. Each EPD is slightly different from the other. How do they work? What's the best? And which ones should we be working towards or advocating for? So let's start with our product-specific EPDs. So product-specific EPDs are really important because it's really fundamentally focusing in on a specific manufacturer. It's focusing in on a specific product, hence the word product-specific EPD. But it's also something that we want to be able to highlight as being a third-party verified actual EPD. This is really quite an important piece because there's a lot of EPDs that are out there that are not necessarily third-party verified. And this is an important criteria because it ensures that, you know, if it was a manufacturer that's doing the EPD, it's not the manufacturer reviewing the quality of the EPD themselves, but rather somebody else, third-party representative looking at it that's qualified, that's looking at the actual EPD to say, you know what, it is following the criteria, it is following the international standards, it is following the actual requirements outlined in the product category rules. So this is really quite an important piece. So type 3 product-specific EPDs is something that we should be asking for. Group EPDs is from essentially a single company, but it's creating a series of products that are all somewhat similar, but it's really looking at them as a whole. So kind of creating a group of all of them together. So it could be a series of sealants that are somewhat similar. Maybe it's a series of insulation or materials that are somewhat similar that maybe just have a variation between one another. They just sort of clump them together and call them the group EPD. So it's one set of results that's representative for a variety of different products. So industry-wide EPD, this is also something quite interesting. It has a number of other names. It's also called your generic EPD. It's called your sector EPD. It's also called an average EPD. But this is really talking about how there are different manufacturers that have similar products from one another that they then group together as a kind of consortium of sorts of manufacturers to say, look, overall, as an average between my product, Joe's product, Jim's product, this is the sort of general global warming potential or carbon value of all of our products because they're all somewhat similar. So that's really looking at your industry-wide. But it is defined by your sector and or your geographical area. That's really an important piece, but also as it relates to, as I mentioned earlier, your product category rules. That's really what's defining your average EPDs. So in the scale of accuracy, industry-wide has its place. It does work, but it's not going to be as accurate as your product specific because it's not really talking about the specific product that each of these manufacturers are working at. It's more of like a broad stroke, kind of an average between the two or more. The other one is really looking at our manufacturer comparable data. So it's really product-specific EPDs that are kind of similar to one another. So for example, if we were looking at in our standard specification, a product that we wanted to be able to substitute with a low carbon product, we would say, okay, this product that we have in our standard specifications doesn't necessarily have an EPD, but there's another product specific EPD out there that is of a low carbon product that is very similar to this. So that's something that we can compare it to. That's something that we can replace it with. So it's really looking at two product specific manufacturers and how they can actually relate to one another. Although it is product-specific data, you have to remember that it is still comparable. It's not actually the exact same thing. It's you're kind of utilizing the assumptions and the subjective perspectives of it that you might have that might work. So I might choose a manufacturer data or EPD. You might choose something different, but it would be for the same product that we're trying to substitute. So there is also other comparable data. What's the difference between other comparable data versus manufacturer comparable data? So really this is where it's having to do with, it doesn't allow for product specific comparisons. So your manufacturer comparable was looking at product specific EPDs and comparing them. Other comparable data is just looking at EPDs as a whole. Maybe one of them's a product specific, maybe one of them's an industry average, and really just saying, okay, just given the lack of information that we have, how do we actually make this work? How do we kind of make the assumption and kind of bridge all those things together? So that's really your other comparable data, but you can kind of see with each example, it's getting less and less accurate to the point where there literally is no data available. And that's clearly defined by the red X that you see there. So for the purposes of our investigation, for the decarbonized set of specifications that we wanted to be able to do, we really focused in on EPDs that had data, quality data. This is really important. So anything that you see kind of in that threshold line there, that dash line onwards, where it's really looking at your comparable data, whether that's manufacturer or other. And of course, if there was no data available, what we simply did was acknowledge that there was that sort of scale of EPD, where there was no data, manufacturer comparable or other, and then we just left it at it as is. We didn't kind of dive into it even more because we didn't want to sort of risk the sort of level of inaccuracy in the exercise. We wanted to keep it as high quality and as really accurate as possible. So with all of this process in mind, with all of these EPD types in mind, with the goal in mind of developing this decarb spec. How do you actually put all of these pieces together? So really, this came in the form of what we're calling a spec carbon chart. Really, it's basically essentially an organization of all of these pieces together, and sort of outlining that into a really clear organization. And again, our sustainability team really helped us in organizing that. One of the things that we actually sort of did in this exercise is, for the sake of process and ensuring that we're meeting each target, each goal as we went through the timeline of our schedule, is we actually broke up the spec carbon chart into two specific parts. So the first part is really just looking at what is our manufacturer, what is the product name, what division and section does it actually sit under, what is the actual product type? Is it your standard specification? Is it your low carbon product, your alternative? What is the carbon value of that product? And any subsequent notes. So I do want to highlight in here, just as it relates to the carbon values, is we only looked at identifying the carbon value, so your functional unit, your global warming potential, et cetera, really looking at all of that for our standard products for this part one. For the actual low carbon products, all we did was put the product name, manufacturer, EPD type, and we just left it at that at that moment in part one, because we wanted it to sort of funnel through the actual spec writer team to be able to understand and vet out what those products were. Whichever products were vetted out, which is part of part two now, those would be the products that we would then continue the exercise of outlining what the functional unit was, what the global warming potential was, et cetera. So that vetting process is really the bridge between part one of the exercise and part two of the exercise. I did want to highlight two additional notes in here, which I think was quite important. We talked about really building up the spec carbon chart to have essentially kind of your qualitative matrices, but also as it relates to your quantitative matrices. So from a qualitative metrics, we really wanted to be able to highlight, and again, this was one of the recommendations from our sustainability team, and a really good one too, just as it relates to not just your carbon, but talking about your health, talking about the actual waste reduction. Is it a recycled product? Also talking about the water and usage. This is another piece. So all of those sort of qualitative aspects, not necessarily pertaining to your carbon value, but more so pertaining to carbon and everything else. And I think this was quite an important line item in there, because a lot of our clients are saying, well, you know, in my mind, this product and that product are basically the same based off the global warming potential that you guys had found through these EPDs. But you know, how do I kind of break the vote? How do I kind of break the tie? And the only way to really do that is actually look at the qualitative aspects of that product beyond your carbon value. And I think that was a really sort of beneficial line item to add. I did want to also highlight the quantitative metric, and this was something that I specifically wanted to be able to add in there as an easy metric that we would be able to kind of distill down and highlight. Basically, it's essentially showing you what the percentage of carbon is of that product within its respective division, but also as it relates to the percentage of carbon of that product within the actual overall specification. So from divisions 3 through 9. And that way, say, for example, if my client were to come to me to say, you know what, Lara, this is all great. I don't know what any of it means. I just want to have 50 of the top 50 products that are the highest carbon in value. I just want to know what they are and see what those respective low carbon alternatives are. So really being able to have a quick filter in your Excel file to say, okay, for sure, this is of the 600 some odd products, this is your top 50. This is your top 100. This is your top 5. Not just within your division, but also within your actual whole spec. So that was really something that I really wanted to be able to implement as an easy identifier for us to be able to communicate with our clients, and also for our own knowledge, frankly, to be able to understand where the high carbon sort of values were. That I think was kind of an important piece to be able to define. So this was the kind of process and defined terms, but what were the actual findings? The findings were really quite interesting, actually. And the way that I've broken it down as part of this webinar is really looking at our standard products, but then also our low carbon alternatives. So let's just start with our standard products for now. You can see in the slides as it relates to the color metrics and the percentages, I'm following that sort of taxonomy of sorts of those EPD types. So really looking at our most accurate of our product specific right through and into our no data available. But what we found very, very early in the exercise is the significant lack of data out there as it relates to carbon. It was shocking, honestly, even like within the first few weeks to a month, where we were just amazed that there was just no EPDs for us to be able to accurately quantify what our baseline was. And why is that important? Why do I need to know what my baseline is? Well, it's because if you don't know what your baseline is, you can't really understand what your offsets are in your decarb spec. But also it means that any sort of offsets that you do hypothesize thereafter is going to be skewed. It's going to be off. It's going to be not accurate. So it meant that we needed to be able to have data, and there just simply was no data. I do want to highlight in here that that's 72% of products that did not have EPDs available. This is really important to know. This is a moment in time. So this sort of exercise that we've done was really something that was concluded at the end of December 2023. So as you can see, it's November 2024, an entire year practically has passed. What have we found from then to now? I can tell you in calling these industry manufacturers, talking to them about EPDs, asking them if they really do have an EPD, maybe it's just not public. That's also another thing. Sometimes they have EPDs and it's not published. This number has changed for the better. It's not as good as it should be. This should be 0, meaning every product has an EPD. But I can tell you from then till now that it has gone down. So the trajectory is there, but we as architects should build that momentum in working with our manufacturers and speaking to them about this. I also want to be able to highlight specifically that these are the value or percentage that you're seeing here, that 72%, is of the products within the specifications, our specifications. So from 3 through 9, this is not taking into account the structural engineer specifications. This is not taking into account the interior designer specifications and so forth. So understanding that this is sort of that moment in time, A, and B, that it is just of our architectural specifications is important to note, because I bet you if you were to underlay your structural eng, your interior designer, and whomever else that's applied or applicable as part of your divisions 3 through 9 to be able to do their own assessment as well, this number would also probably change. So this is where we are at as it relates to, or where we were at as it relates to our standard products. I want to be able to highlight what we found as it relates to our low carbon alternatives, because this was also quite an important piece to the exercise. The findings for the low carbon alternative were actually split into 3 segments: general issues, location, and testing and co-compliance. So just starting with our general issues, this is where BBS and our spec writers came into play in full force to be able to understand and vet what those products were. What we found as a whole is that those low carbon products actually didn't exist anymore, or for example, they were limited in its use or application. In some cases, they were actually bought out by another company. Their name has changed. Their data sheet is actually in another language, or doesn't exist anymore. And I highlighted again in there 2 particular line items as it relates to it being temporarily unavailable in Canada. This was really quite shocking, but also as it relates to the distribution was not necessarily available in Canada. I would like to note this is not all the low carbon alternatives that were proposed. Rather, this is of majority of those low carbon alternatives. I can tell you again, in speaking with other sustainability consultants and even with some third-party verifiers, there are a lot of low carbon products out there, but just of the 300 some odd low carbon products that were proposed, This is one of the key pieces that we found. The other is having to do with location. Around 65% of the products, or a little bit over, were actually manufactured outside of Canada. Why is this important? It's important because we have to take into account transportation. So, for example, if I've got a product that's being manufactured halfway around the world, I have to think about the carbon it takes to be able to transport that product from halfway around the world to port, from port to storage, storage to site. So these are all things that need to be taken into account. Second is having to do with the actual grid, the grid typology that the products are being manufactured in. Not every grid is the same, not every grid is clean. So this actual image is really illustrating the typology of grids that we have, green being better, red being really, really bad. But you can see Canada as a whole is not that bad. US has pockets of bright spots of green, but you can see for the most part, it's actually quite red. So really being able to understand the quality of the grid that you're looking at. So grids that are looking at fuel switching and electrification is really important, because if you have a product that's low carbon, but that's being manufactured in a dirty grid, that any sort of effort being made to create that low carbon product and reduce that global warming potential is fundamentally being offset. So it's just something to take into account. Finally, testing and co-compliance. I kind of alluded to this earlier in the presentation. This was really quite an important piece, and something that was outlined in great detail through the actual vetting process with our specification writer. Around 80% of the low carbon products were not approved for use in Canada. And I put an asterisk there because there's a lot of footnotes to take into account. Again, this is a moment in time. Manufacturers who have actually developed these low carbon products most likely have actually done the required testing. So that's something to take into account. The other piece to this is really having to do with that 80% percentage is really just looking at the total of recommended products. It's not to say that every single low carbon alternative in the world, 80% of it is not approved for use in Canada. That is not what I'm saying. It's simply to say of the 300 some odd products that were recommended, around 80% were not approved for use in Canada. The other piece to this is that the time in which we actually did this assessment was really looking at, again, 2023, there is an alignment of our OBC with the NBC in the coming year. So how does that actually affect this metric? This is something that we'd like to be able to investigate, to say, maybe in the alignment of the OBC to the NBC, that actual 80% may go down, may go up. That's something that needs to be sort of reviewed, and something that we'd like to look into. And again, as I mentioned in the standard products in the previous slide, this is of just our architectural specifications. It is not taking into account the other consultants' specifications and the products within there. But you can kind of see that really that list, the sort of fine print that you see there, really were the top testing and co-compliance issues that were found through the vetting process. Really, a lot of it is having to do with actual flame spread, smoke spread. How do you actually address all of those things? And one of the conversations that I distinctly recall with our spec writer was to say, this is great. This is all about fire, but are there other tests that need to be done? And he said, of course. This is just to actually break into the market in Canada, which I thought was very interesting. And when I asked him, what if we did, say, for example, one product where we had to actually outline each and every single test that it would need to undergo? I'm just curious, what would that mean? He literally said, I'll get back to you next year, because there's just so many tests that need to be done. So many things that need to be able to take into account that is specific to that particular product, whether that's actual fading or that's actual acoustic measures, depending on the product type, whether that's actually testing for your UV, et cetera. All of those things are really having to do with the performance of the product, the longevity of the product. But this is just to break into the market, which I thought was really very interesting. So those were the findings and clearly the information gaps that we found as a result of this exercise. But, we could have very easily closed the books and said, okay, well, clearly industry is not there yet, whether that's simply because the technology isn't there, or maybe there's not enough education, or maybe there's other factors involved that we just don't know. We'll just close the books for now. We'll wait until everything's ready to go, and we'll start from there. But one thing that we really wanted to be able to do is not do that. We really saw this as being an opportunity really to engage with manufacturers, engage with other private sector members, public sector members, and really fundamentally understanding what those challenges are within each of those respective sectors, but also being able to educate and advocate. So this diagram that I'm showing is really the sort of I would say, visual illustration of the work that we did at KIRKOR. So really understanding and recognizing the need for education and advocacy. So really looking at the scales of operation, whether that's our own internal practice, what can we do to educate our own staff about embodied carbon? What can we do to educate our own staff about EPDs, the need for data, and engagement with the respective team of your project to learn more about these things, but also as it relates to the macro level and the external factors. Again, I put manufacturers first because I really believe that they are the linchpin in this discussion. They need to be engaged and working with them and talking with your clients and developers, working with your public sector, and really engaging with the full team. So your industry experts, your sustainability experts, your engineers, and even your third-party organizations and verifiers. They all have a role to play. They all have things to say. They all have their own respective challenges. So channeling all of those discussions through education and advocacy, facilitating those discussions through leadership, and really understanding and communicating what the need is in a very clear and concise way, and advocating for that is very, very important. This is just what we did at KIRKOR. I think everybody has their own strategy. I think the reason why I wanted to put the slide up here is because I wanted to be able to, again, sharing is caring, as they say. I wanted to be able to ensure that the lessons that we've learned from this experience, we can be able to pass on to others. But this is what we did. But what can the profession do as a whole? So the way I've kind of outlined it is I talked about it as being small incremental steps. We're not talking about monumental moves here. We are simply talking about, picking up the phone and calling your spec writer. That's a small thing to do. Anybody can do it. If I can do it, you can do it. An intern can do it. A partner can do it. Everybody can do it. It doesn't matter what rank you are, what sort of knowledge that you have on the particular product, but just picking up the phone and calling people. These are the small steps that we can do, and they have lasting impact. They have big changes. And if we can all do it together as a profession, I think there is possibility for change. So the way that I've actually broken down our takeaways and what those opportunities are is really looking at what those gaps are. So there's gaps in processes, there's gaps in information, and gaps in the tools. So let's talk about gaps in process for a little bit. There is that issue, as I mentioned, issue in specifying those low carbon products without having done a vetting process. And I think this was one of the key pieces that, having our spec writer on board, not just for understanding how we can channel the embodied carbon life cycle stages through and into the spec, but also just understanding how does it work? How does it actually translate as it relates to the low carbon products? Can we actually implement them? Can we actually use them? So they were really helpful. And I think that was because we were all very interested. We were all very curious about the process. And I say be inquisitive because I think it's really a summary of what it is that we did. We were all very excited about it. And I think that excitement really helped us kind of drive the discussion and really think about the nuances of everything. So learn about your products. learn about their limitations, learn about the EPD limitations. I think that's really also important. But also fundamentally understanding the analyses of your spec, understanding how it can be decarbonized. And again, as I said, work with your spec writer and your sustainability consultant. They are really very important to this process. And again, highlighting that the spec is the tool that we have at our disposal to be able to say, okay, this was the actual goals that we had set out in our studies at the beginning and design stage and design development through those life cycle assessment reports. But let's actually talk about implementation. Let's talk about execution and verification. Your spec actually addresses that. So understanding that this will help in sort of bridging that gap. I mentioned gap in information here. This was a huge learning curve for me personally. So educating yourself is really an important piece. Ask the questions, ask your team, ask your consultants, speak with the industry manufacturers. You'd be amazed at how much you'd learn from them. And I put it in here an important note of just what are you asking for? I think this is really very important to know, because we shouldn't consider this as being a kind of like a checklist item. Okay, I've asked for EPDs, check mark. You have to understand what an EPD is. You should learn about it so that when you actually have those conversations with industry, when they say, well, what is an EPD? What are you looking for? Why is it important? You can actually have a comprehensive discussion with them. And frankly, you'd be able to have that much more success in setting them up for success as it relates to making sure that they have all the tools at hand to consider with regards to actually creating the EPDs. So really knowing what we need EPDs for, why we're asking for it is very important. So educating yourself and educating industry and others, I think is really important here. So I noted gaps in tools, and I'll conclude with this. I said, or so it seems, because really we have the tools at hand. We talked about it earlier, the scales of the spectrum of decarbonization strategies. Design and broad stroke strategies as it relates to efficiencies and structures, as it relates to less is more, less material is better for having less carbon. These are all things that we know. These are all things that we do all the time. It's not just as it relates to an effort for decarbonization, as it relates to an effort in reducing embodied carbon in our buildings, but frankly, I would argue it's even just good architecture. This is just good design. You'd want to be able to streamline your structures. You'd want to be able to minimize your transfers. That's just good design. But what is it that we need to be able to consider as it relates to the execution of all of those strategies? What tool do we have at hand to do that? And it is the specifications. I can't drive that home any harder than I have already have. But really being able to execute that. And I would also suggest communication and engagement. Again, as I mentioned, internally, externally, and even with your clients. This is another thing. Educate them on what it is that they're trying to achieve. Do they really understand it in full? So I think all of those key pieces are small takeaways, small steps that we can all do to really be able to create big changes and hopefully really have the success in decarbonization. So Felix, I think I was able to fill in that time well. So we're right at 11:58.
Yeah, that's perfect, Lara. And this is just a reminder, if you have any questions for our speaker, Lara, today, please post them into the Q&A window. Lara is going to address all these questions now. Thank you.
Great. So I'm just going to walk through the questions here. We've got one from an anonymous attendee, just as it relates to, will the slides be shared after the presentation? I think, Felix, you mentioned that it would be, right?
Yes, exactly. So after the webinar, all participants are going to receive an email with a link to provide the feedback and, of course, with the presentation slides.
Okay. So we have another question from Daniel, just as it relates to, and I'll read it out here. Does the quantitative data on high carbon materials get project specific in relation to the relative amounts of each material being used in the building? Or is it top 5 or top 50 list just at the spec level, regardless as to how much of the product is to be used on a given building. So I'm going to try and unpack that a bit. So does the quantitative data have high carbon materials get project specific in relation to relative amounts of each material being used in a building? Daniel, this is a bit of a wordy one. Okay, so maybe what I'll do is, and I hope that this kind of answers your question, the sort of concept of the quantitative data is really being able to highlight every single product. It's not the top 5. Okay, so I think I'm understanding your question. It's not necessarily your top 5 or your top 50. It's literally going to be, in our case, the 625 products. So listing all of that in line and being able to understand in order from highest to lowest carbon what that spectrum is. As it relates to it being project specific, not so much, because this assessment that we did was looking at our master outline specifications. Master outline specifications means it's the full library or database of materials. We actually draw specific materials from the master outline spec for a project spec. But it's basically like the full, it's the full database, really. And that's one of the other things that if I could maybe add to this conversation is that don't look at this decarb spec on a project by project basis. Consider it as part of your master outline specifications, because that's really where you have all the materials at hand. So something to be able to consider for that. I hope, Daniel, that answered your question. There's another Q question in here. Has there been review of peer-reviewed studies on GWP of products without EPDs? Great question. We did not do this as a peer-reviewed study. We just worked on it with our team with BBS and HAF. But I think to your point, peer review is never a bad thing. It's actually a really great way of verifying the investigation and ensuring that the data that has been pulled or drawn from the exercise is vetted. As we've said, vetting the low carbon products, but let's just vet the entire process itself. I think that's a great question. I can say, and I think I might have mentioned it earlier in the presentation, that because this was really a moment in time, this was another reason why I actually called the manufacturers to say, you know, we're doing this exercise. This was the data or lack thereof that we had found or did not find. Do you guys maybe have an EPD that we just don't necessarily know about? Again, because it's not necessarily being published, or perhaps, you know, we may have missed something. You never know, because this is a lot of products. So certainly in those conversations, as I mentioned earlier, we actually found that there was a number of products that actually had EPDs that maybe we just didn't know about at the time. And in some cases, especially during this particular year, there was a number of manufacturers that were actually working on developing their EPDs. So it wasn't published at that moment in time, but certainly during this year, it actually was. So that metric certainly has changed. So I think that 72% is something to take with a grain of salt, but at the very least, it was a clear indicator that there was work to be done, that there was education to be made and had, and conversations to be had. And certainly the drive for EPDs is really part of that discussion. So I think there was only 3 questions thus far, but I'm happy to be able to answer any further if there were.
Yeah, perfect. Or this seems to be no more. Oh no, sorry, one more question just came in.
So let me just read this one out. Developers would probably know their top 5 or 50 items based on takeoffs they do. Do developers understand that alternatives should be carefully vetted if they want to change? How do we police that? That's a really, really great question. And yes, you're totally right. How do you manage that process? I think really it's having to do with engagement with the developers or your clients specifically, but also as it relates to your life cycle assessment. I think part of the discussion is that, you know, LCAs are really only being utilized at the beginning stages of a project, but how do we actually execute that? And this is how the spec comes into play, because we're really talking about substitutions properly, and it's being outlined in the specifications, which informs your contract documents. So again, as I mentioned, Division 1 being really an important piece to that. So I think that is one of the tools that we can use, is the spec. Is about communication. It's about your LCAs at post construction or at time of occupancy, and really working with your GC too. I think that that's also a key piece. And I think if anything, it's important that we as architects impress upon the developers to ensure, and or clients as a whole, to ensure that their priorities are in fact being executed, because even in between different departments within your client's company, you know, marketing has an idea, the sustainability department has an idea, construction has an idea, and so forth. So making sure that the actual goals that have been set as an objective from the beginning are actually being communicated to the rest of the team internally, from the client side, but also within the actual team as a whole, the consultants, the GC, architects, experts, et cetera. So that execution, as I mentioned, is not just being implemented through the contract documents of your spec, but also being implemented as it relates to the communication within the team as a whole. So really very important to be able to do that. All right.
Perfect. Thank you so much, Lara. Lara, if there are no more questions, do you have any closing remarks?
I would just say, you know, get involved, learn about embodied carbon. It's actually a really interesting topic, and work with everybody, collaborate with everybody, learn from one another, teach one another. And this is one of the reasons why I was so excited to have this webinar, is because I wanted to be able to share the findings and acknowledge everyone that participated too. So there's a lot of really amazing opportunities, and I think if we're all able to work together, not just within our own respective projects, but also as a profession, there's a lot of opportunities. So yeah, get excited and learn as much as you can.
Great, Lara. Perfect. Thank you so much for a great presentation, and of course the Q&A, and for a great webinar and discussion today.
Thank you so much.
Everyone who attended. And as we conclude this webinar, I would like to draw your attention to just some announcements. The next webinar takes place next week on December the 5th with the title IFT, That's It, Except for Addendums. The OAA will report your participation in this webinar to your OAA transcript. Therefore, there is no need for individual reporting on your part. We kindly ask for your patience as we process and confirm the accreditation of your hours within the next few days. Additionally, all attendees will soon receive the presentation file via email, along with a link to provide your feedback. Once again, thank you for your attendance and have a productive and pleasant remainder of your day. Lara, thanks also again very much.
Thank you so much.
Bye-bye and take care.
Bye-bye, everyone.
Bye-bye.